Hello, I'm Uchan Kim, a second semester master student at PRML Lab at Korea University. Now, I will begin my presentation. My project title is Building the Movie Review Classifier. The project objective is to build a classifier that evaluates the positive and negative elements of movie reviews. This model has high applicability as it can be used in various NLP fields such as document classification. My research motivation stems from my desire. As a large language model researcher, I want to choose an NLP task. So I picked the movie review classifier task, which is a famous NLP task. I want to compare the performance of machine learning and deep learning in NLP fields by making two models. I will tell you about the datasets. I choose the IMDb as a movie review analysis dataset. IMDb is a very popular dataset for binary segment classification containing substantially more data than previous benchmark datasets. They provide a set of 25,000 highly polar movie reviews for training and 25,000 for testing. There is additional unlabeled data for use as well. And you can see the 5 head of IMDb datasets and describe of IMDb datasets on the screen. I used the scikit-learn train test split function to split the IMDb datasets into train, validation, and test datasets. You can see the code on the screen. Next, I will explain my baseline model, and I will explain this directly through the Colab screen. First, I imported the RL and NLTK libraries for pre-processing and tokenization and downloaded the NLTK datasets. Then I loaded the pre-generated training datasets and inspected it using head, describe, and value counts function to ensure it was properly loaded into a data frame. Next, I created the function called preprocess text for preprocessing the data. This function performs several steps: convert text to lowercase, removes HTML text, eliminates special characters and numbers, tokenize the text, removes top words, applies lemmatization, and recombines the tokens back into a sentence. I apply the preprocessed text function to the review column in my data frame and store the result in a new column named clean review. By comparing a review and clean review columns, you can see the effect of the preprocessing steps applied to the data. After preprocessing, I proceeded with tokenization. I imported TF-IDF vectorizer from scikit-learn for this purpose. I initialized the vectorizer and used it on the clean review column to extract TF-IDF features and labels. Checking X-train shape, I confirmed that I had 35,000 samples with 5,000 features. Subsequently, I wrote the validation and test datasets, applied the same preprocessed text function to their review columns, and performed TF-IDF vectorization and label extraction using already fitted TF-IDF vectorizer. With my preprocessed and tokenized training data, I began model training. I first chose the logistic regression model, commonly used for binary classification tasks in machine learning. I imported logistic regression, accuracy score, classification report, and confusion metric from scikit-learn. I initialized the logistic regression model and trained it using my training datasets. I evaluated the trained model using a validation datasets, calculating accuracy and generating a classification report and confusion matrix. The validation accuracy was 0.886, which is relatively satisfactory. I then tested the model on the test datasets, achieving an accuracy of 0.89. Since there was no significant discrepancy between training and test performance, overfitting was not a concern. So I did not implement any post-processing steps like dropout. Next, I explored deep learning by implementing an LSTM model, known for its strong performance in NLP tasks. I imported the TensorFlow library and set a vocabulary size limit to 10,000 using a clean review column. I created the tokenizer. I converted the text from the clean review column in training, validation, and test datasets into sequence, set a maximum sequence length to the 85th percentile to accommodate most data, and apply padding to standardized sequence length. Then I initialized the model embedding n LSTM layers and included the dropout layer to prevent overfitting. The output layer uses the sigmoid activation function. I compiled the model with an Adam optimizer and binary cross entropy as a loss function. After setting a number of epoch to 5 and batch size to 128, I trained the model. However, when evaluating the LSTM model on the validation and test datasets, I observed low prediction accuracies around 0.5. And visualization indicate that the model was overfitting to the training data. And by visualizing the model training, we could detect overfitting situation easily. To solve the overfitting problem, I simplified the pre-processing steps, add OV token to the tokenizer to map out of vocabulary words to specific token, reduce fixed maximum sequence length to prevent overfitting, simplify model architecture by decreasing the number of LSTM units, and increase batch size to improve generalization performance. After doing this, it shows enhanced validation accuracy up to 0.8756 and test accuracy up to 0.8853. And also by visualizing model accuracy during training, we could see overfitting problem is solved. I developed two kinds of movie review classifier using both logistic regression and LSTM models, both of which demonstrated high performance. While I initially encountered overfitting with the LSTM model, I solved this by simplifying the model structure. Typically, deep learning outperforms machine learning, but due to the relative small size of IMDb datasets, both models delivered similar results. My code is available on GitHub repository displayed on the screen. If you have any question, please feel free to contact me at the email address provided. Thank you for your attention and for taking the time to listen to my presentation.